In 1958, the world was captivated by the race to explore the unknowns of space. The U.S. had recently launched its first satellite, Explorer 1, which quickly became an essential milestone in the early space race. The scientific discoveries made by the small spacecraft would forever change our understanding of the cosmos, the Earth, and the very nature of space itself. But what most people didn't expect was that nearly 66 years later, Explorer 1 would still be in operation, its systems pushing the limits of aging technology and sending data back from the furthest reaches of our solar system. It's hard to believe that a small satellite, launched during the early days of space exploration, could outlive almost every expectation. NASA had originally intended the mission to last just a few months, 5 years at the most, but the spacecraft defied the odds. Today, Explorer 1 stands as a testament to human ingenuity and the resilience of technology. Though it's no longer operating at full capacity, the satellite still serves as a link between Earth and the outer reaches of our solar system, continuing to provide valuable data about our environment and the universe. In 2024, NASA faced another challenge with Explorer 1. On October 16, communication with the spacecraft was unexpectedly lost. This wasn't the first time, and given its age, it wasn't the last time either. Despite the technical issues and the immense distance separating Explorer 1 from Earth, more than 24.7 billion kilometers, NASA's engineers remain determined to keep the spacecraft operational. They've done it before, and they were ready to do it again. What caused the issue this time? The problem began with a seemingly simple command: turn on one of the spacecraft's heaters. These heaters are crucial for maintaining the temperature of the spacecraft's systems, especially in the harsh environment of space where temperatures can plummet to hundreds of degrees below freezing. When the heater was activated, the spacecraft's error detection system was triggered, causing a series of unforeseen issues that left engineers scratching their heads. NASA engineers quickly realized that the error detection system had overloaded the spacecraft's power systems, which resulted in the loss of communication. For days, engineers scrambled to identify the cause of the issue, with time running out to fix the problem. But they weren't just fighting against time, they were also fighting against the challenges posed by the distance. With the spacecraft so far from Earth, every message takes 23 hours to travel in one direction. So, for each command that was sent, the engineers had to wait almost an entire day before receiving a response. It's a tough situation, but it's one NASA has faced before. You see, the incredible distance between Explorer 1 and Earth is part of what makes this mission so remarkable. Launched in 1958, the spacecraft traveled beyond the orbit of Saturn in the 1980s, and by the 1990s, it had surpassed the boundaries of the outer solar system. As of 2024, it's floating in the great expanse of interstellar space. This means that even though the spacecraft was launched over 6 decades ago, it's still technically in communication range, albeit in an extremely limited and challenging way. Explorer 1's mission was groundbreaking from the start. It was the first U.S. satellite to orbit Earth, and its primary scientific goal was to study cosmic rays and Earth's radiation belts. The spacecraft carried onboard instruments that measured radiation levels in the Earth's magnetosphere, a discovery that had never been made before. Explorer 1's scientific payload led to the identification of the Van Allen radiation belts, a key finding that reshaped our understanding of space weather and radiation around the Earth. But this was only the beginning of Explorer 1's impact on science. By 1981, Explorer 1's main communication systems were no longer in use, and the spacecraft was operating in a mode of extreme power conservation. But as time passed, its instruments, including its primary radio transmitter, began to deteriorate, making communication with Earth even more difficult. Over the years, NASA engineers developed creative solutions to maintain contact, often relying on backup systems that were long since thought to be obsolete. This included the use of the S-band transmitter, a system that hadn't been activated since 1981. At this point, Explorer 1 was using a communication system that hadn't been utilized for more than 40 years. Incredibly, when the X-band transmitter failed in October 2024, it was the S-band system that came to the rescue. Despite the weak signal from the S-band, NASA engineers managed to re-establish contact, confirming that the spacecraft's systems were still functional, at least to some extent. This was an astounding feat, given that the spacecraft's communication system was long past its prime. The engineers at NASA had to adjust their expectations and adapt to the realities of working with aging technology. The S-band system, although weaker, gave them a lifeline to keep the mission going. One of the most difficult parts of maintaining communication with Explorer 1 is managing its energy. As the spacecraft has aged, its power supply has become increasingly strained. NASA has been forced to turn off many of the spacecraft's systems to conserve energy and prolong its life. Some instruments, such as the plasma sensor, have been deactivated for months, while other systems have been limited to the bare minimum necessary to maintain communication with Earth. The spacecraft's power system has had to operate on a strict diet for years, constantly switching off non-essential systems to conserve energy. This careful energy management has allowed Explorer 1 to remain functional for far longer than anyone could have anticipated, but it's also a delicate balance that could be tipped at any moment. Energy management has become so crucial that NASA has had to be creative in finding ways to keep the spacecraft's thrusters functioning. These thrusters are essential for positioning the spacecraft's antennas toward Earth, ensuring that communication remains possible. But with age, the thrusters' fuel lines have begun to clog, leading to further complications. In 2018, NASA engineers had to switch to a third set of thrusters, originally designed for course corrections. However, this third set also showed signs of failure, as the fuel lines became increasingly narrow over time. The size of these lines has decreased from 0.25 mm to just 0.035 mm, a difference smaller than the diameter of a human hair. This issue with the thrusters has posed a significant challenge for NASA. The spacecraft's antennas need to be properly aligned to ensure a connection with Earth, but without the proper functioning of the thrusters, that task becomes nearly impossible. In response, NASA has had to switch between thrusters multiple times, attempting to find one that works. Each time a change is made, there's a risk that the spacecraft's systems might be overloaded, consuming too much energy and causing a catastrophic failure. In August 2024, NASA decided to make a bold move to address the thruster issue. They chose to temporarily shut down one of Explorer 1's primary heating units in order to conserve enough energy to heat up the thrusters. This risky decision paid off when the thrusters were able to warm up, allowing the spacecraft to reorient its antennas toward Earth. However, this fix is only temporary. The heating unit, while crucial for the spacecraft's survival, is now on borrowed time, and any additional failures could cause irreversible damage to the mission. The countdown for Explorer 1's mission is now clearly in sight. While the spacecraft has continued to perform far beyond its expected lifespan, NASA scientists estimate that communication with the probe will likely be lost by 2036, as the distance between Earth and Explorer 1 continues to grow. At that point, the spacecraft will be so far from Earth that its signals will become undetectable. The spacecraft's systems will eventually degrade beyond repair, and the mission that has lasted for so long will come to an end. But even in the face of this inevitable end, the story of Explorer 1 is one of incredible resilience and human achievement. Explorer 1's journey through space has been filled with unexpected challenges and triumphs. What was initially supposed to be a short mission has turned into one of the longest-running space operations in history. NASA engineers have had to adapt to new technologies, face unanticipated failures, and overcome seemingly insurmountable obstacles just to keep the spacecraft operational. It's a story of innovation, persistence, and a relentless drive to explore the unknown. As the mission draws to a close, it's clear that the legacy of Explorer 1 will continue to shape the future of space exploration. The lessons learned from this mission, about power management, the resilience of technology, and the need for creative problem-solving, will be passed down to future generations of scientists and engineers. Explorer 1's journey is a testament to the power of human ingenuity and the unyielding spirit of exploration. Its impact on our understanding of space weather, radiation, and the Earth's magnetosphere will continue to inform scientific research for years to come. Even though the spacecraft may not be able to communicate with Earth much longer, its mission has had a lasting effect on the field of space exploration. In fact, it's a reminder that even in the vastness of space, where conditions are harsh and technology often faces extreme challenges, the pursuit of knowledge can triumph over adversity. The end of Explorer 1's mission will be bittersweet, but its contributions to our understanding of the universe are invaluable, and its place in the history of space exploration is secure. Explorer 1 is more than just a satellite, it's a symbol of the human spirit, an enduring reminder of the power of curiosity and perseverance. Even after more than 60 years of service, it continues to defy the odds, and its story will inspire space explorers for generations to come. As NASA prepares for the eventual end of this historic mission, we can look back with pride at what has been accomplished and forward with excitement at what lies ahead in the boundless frontiers of space exploration.